So today we're going to be doing some folding, some shrinking to create these profiles that are arched at about 180 millimeter radius. It's got a 25 mil lip, 100 mil wide. Part of the project I'm designing, I need about 30 linear meters of this, and I needed to make it fairly easy to build. So we're folding it on our folder in pieces, and then we're shrinking it, shrinking these edges to get them into shape. Today's video is about working out what the capacity of our machine is to make these in reasonable volume, and what we need to achieve the final product, which is going to be a rotational mold that needs some ribs on the circular flange of it. And yeah, hope you enjoy the video. Okay, well, I guess the first job I've got to do here is put the folder back together now that we're in the new workshop. We take all the bits of the folder, reassemble it before we can start folding those edges to put the curve on. I will start with that and probably speed it up for you guys because it's going to be super boring to watch all of that, and take it from there. So these have all been cleaned up after they haven't been used, and the units come out of storage for the last, been in storage for the last almost 2 years without some use. So everything had a little bit of rust on it, which we've cleaned up with a fine Orbital. And now we've got to put all the pieces back together. I'm just loosely going to put every piece in and then start tightening them up. So there's no right or wrong way to set these units up. Typically, whichever manner you put them, you're going to need them in different spacing and going to have to move them around to fold up boxes. So I'm just trying to keep it as random as possible, big, small, small, big. Having a split tongue brake definitely allows you to form boxes, but it's a lot more work putting it back together and getting that line all perfectly straight through there. I'll start with this big double unit because that's the easiest to square up. I'm losing my B-roll camera, it fell over. When first you don't succeed, put a clamp on it. It's not bad, there's a fraction of a millimeter difference there, but as you press the tongues down, they do level themselves out when they clamped a piece of metal. That line there feels pretty good, less that one. Last two pieces to put in. Okay, just go around and give everything a good tighten. Okay, so what I'm trying to create is this three-dimensional rib. Need it to be about 60 millimeters deep and an 850 radius. So I've got a sample, and this is our test piece. This is really just a test project. What we're going to do is we're going to put some 30mm lips on the end of this, and the rib needs to be about 100 millimeters, so this is 160. And we're going to fold that in the folder, and then we're going to attempt to shrink 1.6 mil so that it rolls to a 850 diameter. Personally, I think I'm stretching the limits of our shrinker, but you never know unless you try. That's why we're trying this. So this is attempt number 1. So just as a guide, so that we don't have to make this one perfect, just so we've got something to follow on the bench is a roughly 850. And we'll take this, I'm gonna go get a pen and a marker. So we want a 30mm fold, but I've also rebaited the folder back because this is gonna end up being a plastic mold. And we don't want this corner to be extremely sharp. I need that to have a bit of a radius in it to form the plastic. So we'll probably go 5 mils back for this test, see where that lands up. So we'll mark them at 35. Mark the side at 35. And then we'll go back over to the folder. Okay, so I've set the back stops. We'll double check those. That distance there is 125, which from the edge of the folder is 6 millimeters back, which is a millimeter less than our allowance for the radius. And if we double check that, we are 125, 127, okay, we're 125. We'll lock the folder here. And lock the backstop again. Okay, position the sheet metal to the lines. And put a 90-degree fold on it. Now, unfortunately, one of my staff members crushed the electronic dial measurement, so we're going to have to eyeball these. Slightly over. Knock that off. And time to pull hard again. Fraction more. $90. Close enough for this application. Okay, so now we've produced a C channel, and what we want to now do is make this C channel round. And that's going to require a lot of shrinking up on this face, and shrinking 1.6 mil is definitely going to be a challenge. The overbend is a little bit much, unfortunately, but there's going to be a bit of tapping and bashing and grinding, and should be able to potentially fold it a little bit in the shrinker. We'll move the camera over there and get set up. Okay, we're all set up at the Shrinker Stretcher. Well, this is just a shrinker at the moment. Need a second unit so that you don't have to change all the bits. Let's see what it does. Okay, there's a little bit of shrink in there. Okay, we're starting to get a little bit of curve on that. There's a very, very long way to go. Okay, I'm going to start doing obviously, if you look at this area here, this side needs to shrink more than this side. So those are all really deep shrinks right up to the edge. We'll try and do some half shrinks to pull this area over. We should get a little bit more movement doing that too. Now you'll see this whole shape has gone out of whack because the side we've done the small shrinks on is fighting the opposite side. And with a little bit of luck, as we pull over the other one, it should come back to a flatter shape, because at the moment it's got a lot of stresses that have squashed the metal there and not as much over there yet. It has improved, but it's quite out of shape. As this pulls around more, we need to shrink the areas that haven't bent as much compared to the areas that have bent a bit more. The shape is extremely rigid now. There's almost no twist in there. So your shrinks are going to be changing the flatness of that shape, but at the moment that's not quite going to work for what I need it for. Getting more and more shape in that. Starting to smile. Still a little bit of unevenness. Now, what I should have done is drawn lines every 50, 60 millimeters so that I had even shrinks on both sides. And then followed those lines and done deep and narrow, deep, narrow shrinks all the way down there. I think I'll do a deep shrink right the way through the whole piece again. Starting to get a lot more evenness back into that from that deep shrink. Go and have a look at our template. Follow me here. It's got a long way to go. This might be too much for 1.6 mil with a 30 mil lip. I'm not going to give up just yet, but if I point you at that, you will see that the line is this is the line there. Okay, we give this a bit more. I don't think I'm going to get that, what I wanted out of this shape. it's a lot of shrinking still to go. And I don't think the shrink is quite man enough to achieve it. Might try and trim off 10 mils, take it down to a 20 mil lip. The key was to be able to join this to another piece of metal with a return lip the other way, and create a ribbed section with a nice radius on the inside. That's all looking fairly smart, but just trying to shrink this much metal. If this was 24 gauge or 20 gauge, it may bend around that shape. But as 16 gauge, bearing in mind I've got 5 full circles to make at 1.8 meters, 1.8 meters, and that's only a very small portion, probably a quarter of it. So building that 40 more times would be probably a new Shrinker Stretcher times 2. The teeth probably wouldn't survive that long making that many of these. So I'm going to go mark this out and see if I can trim it down, bring it down to a 20 mil step. Might be easier just to fold a new piece, cut up a new piece, fold a new one, and try that at 20 mils, see what it does. Okay, get set up over there. Okay, so I'm gonna cut a new piece, and instead of 160 mils, I'm gonna cut that at about 150. Because this is test work, might just make this a little bit shorter too. There's a lot of work in folding these. So would be nice to have a guillotine right now, but unfortunately don't have one of those yet. So we'll cut it on the nibbler. Okay, so one cut through here. Okay, so that gives us a nice cool little looking spring thing. Scrap metal. I'll quickly clean this up, take this welding splatter off. It's just a bit of scrap steel to do an experiment with. Okay, and now we mark this at 120. At 20. So I'm going to go 22 and a half because I've got about a 5 mil radius on there. And from the last one, at that radius, it's roughly what I need to get this to form correctly. Okay, so I've got my 4 little marks on there. Take it back over to the folder. Okay, now we've got a channel a lot smaller than the last. It should be a lot easier to get that shape that we're looking for. The length is just more work, but the formation is the hard bit. I've got one side almost perfectly square. The other side is about 1 or 2 degrees out. Just give it a touch more, square it up now. And there's our 100 millimeters. Okay, let's get set back up at the Shrinker Stretcher and see if we can make this work. Far too much. Far too much shrinking. Bugger. Have a look at this, guys. That just moved far too quickly. So let's give it another cut. Let's see how it looks. It's not coming out too badly. It's got a little bit of a twist in it, but I just went too hard on the stamper too quickly and put too much curve in it. So this channel is not about being perfect. What it is it's about a bit of learning, you know, a bit of understanding about what we're doing, what we're trying to make, and pushing the boundaries of what we have made. And typically I'd weld this inner edge up and join 2 sheets up, but it's quite hard to get a consistent radius on this inside edge there. Whereas if I butter another piece of steel up to there, that's a fairly easy and continuous weld. And at 100 mils wide, you can get a grinder in and clean that up relatively easily. Okay, let's do another one. I think the next version I'm going to put some marks all the way down there with the vivid, and probably shrink just the edge, not go not do a full shrink all the way, and see how that looks, or keep the distance a bit further apart, just to pull it over. We're thickening all this metal here by shrinking it, so we'll be able to grind that and get that face back to mint and perfect. And yeah, not going in quite as deep, won't get these little teeth marks that we're getting in over there. Okay, let's cut another one. Scrap number 2. Okay, so this last trial, hopefully this is the working unit. I'm going to cut at 150, which is going to give us about a 25mm step. So the very first trial was a little bit over at about 35, which should have been 30. The second trial was about 21, 22mm, which was supposed to be 20. And this one we're going to attempt to go to about a 25mm lip on it. Let's give that a go. Okay, so we're going to mark this piece out at 25mm increments as the next trial and the next test. Give this a quick lick with the Orbital, get rid of the bit of weld and splatter, because this is just a little piece of scrap metal. There's a little bit of sharpness on that edge. Okay, new piece of metal. Set this to, so the last one we set at 25, 22 and a half, so we're going to go 27 and a half on the measurements for the fold, because we actually got more shrink in the side walls than we expected, with a lot less effort than we expected. So hopefully the middle ground will make it hard enough to fold, but not too hard that it's impossible to fold like the first version. Okay, let's go to the folder. Okay, we've got the folds ready for a 25mm offset in 16 gauge. Close enough. Okay, it's looking pretty good. We're about 103, which is a little bigger than I wanted. Got to get those marks perfect, because I've got such a large radius on the corners over here. It's not a straightforward measurement like on a press brake. Okay, so this time, instead of just going hell for leather, we're going to put a couple of marks on here to mark out where we want to put our shrinks so that we have a better understanding of exactly where we're going. So I'm going to mark every 50 millimeter, roughly 2 inches. I'm in New Zealand, so metric system all the way. Just going to square these lines up. And this is not about being absolutely bang on perfect, it's just to kind of keep the symmetry going. The first 2 units were a little bit rougher, and that enabled me to figure out what the ability of the shrinker was and how much metal it was actually going to be able to shrink over. So I'm also going to attempt in this round to shrink top, then bottom, then top, then bottom, all the way through. We'll give that a go and see how it looks. Let's go over to the shrinker. Okay, so this time I've got some zebra stripes all the way down the unit, and I'm going to attempt to do a shrink here. I'm going to shrink there, shrink here, shrink there, shrink here, shrink there. Oh, 1, 2. But just keep the symmetry a bit better, stop the unit from twisting. That is a fairly consistent placement. I'll do a half in the center of each fold now. Okay, fairly consistent. This side is slightly deeper than there. We could run a couple more shrinks just in this region there, would be good. Okay, the symmetry is awesome this time. That panel is looking nice and flat in profile all the way around. And I just quickly wander over and see how far we are. We are so close to where we need to be at that radius. It needs the smallest of little bits to go. I'm just going to do one every second. Okay, let's go check it out. I think we're just about there. So I'm not saying it's absolutely perfect. Let's turn. Turn the camera around for you guys. That's the line. I'll offset it so you can see the line a little bit better. There's enough flex in that, and you know, you'd be able to pull and twist that to get it right. But that is bang on the shape we wanted. It is fairly flat, not absolutely perfect, but I think you would get a ability to get a little bit of twist out of this without too much of a problem. So that's us building our first of our ribs. I think our final product has turned out awesome. We've created the shape we needed. This is pretty thick metal at 1.6 millimeters or 16 gauge. We've got no really bad scuff marks to clean up on there. A grinder or a sanding disc would clean those little burrs up very quickly, and I'd probably only do that after welding. So looking at our first attempts, I was just asking this piece of metal to do too much. I know it's a longer piece, but with this big lip, I was just, it would be doable, but I'd have to be shrinking this. It'd probably be a couple of hours worth of work in every half meter piece like that. And I'm gonna need about 20 meters of this channel rolled in 16 gauge to form part of the next little project that I'm busy with. So pretty stoked with that. The second attempt we did just went absolutely way too quickly. I struggled so much with our first attempt, and I jumped on the shrinker just way too hard, just did way too many shrinks. You can see how much shrink marks that this has actually put through there. Compared to the final, it's very minimal. We didn't need to work that as hard, and I've actually got a bigger lip on the final version. Turn off the tracking. I've got a bigger lip on the final version, and it's the right shape. So guys, with a bit of persuasion, managed to make the test. Now I can go through the rest of the design process and build design the project around what I can form and what I can build. Sometimes you've got to jump into the workshop, work out what your machinery, what your equipment can achieve. There are obviously other ways of making this. You could have welded up corners, you could have, but in our process, and what I'm using this for is a plastic rotational mold, and we need soft, gentle corners on the inside edges of these to make the product that we need to be as easy to trim and look as attractive as possible. And that is pretty much created exactly what I'd like to see. So yeah, thanks for watching guys. Catch you on the next one.